G'day and welcome back to the garage. In the last episode we completed the disassembly of the bike, which left us with an engine, a frame and a bunch of other parts. In this episode we're going to focus on the engine, tearing it down and inspecting its condition along the way. This should leave us with a good idea about what parts are required to be replaced or restored. Let's get started. So with the head off the engine we can see inside for the first time, and there's a couple of surprises already. One's the head, there's some damage here which looks like something's been bouncing around inside. And two is the piston and bore, they look very close to new. Well, let's keep going and see what else we can find. So this is the power valve, or as Suzuki call it, the AETC, or Automatic Exhaust Timing Control. On a two-stroke engine, the power valve changes the exhaust port timing in relation to the engine RPM. This allows the engine to have a broader power delivery. You can think of it a little bit like variable valve timing in a four-stroke engine. There's a governor assembly down by the crankshaft that actuates this rod and lever, and that in turn rotates the power valve shaft. Connected to this shaft are the valves themselves. And here's a better look at that piston. You can tell by the small amount of carbon build-up on top that it really hasn't done much work at all, but unfortunately there's some damage to both skirts on the exhaust and intake sides. I'm not sure what's happened here, so we'll keep looking. As the power valve comes apart, I'm really surprised in the condition of this whole assembly. There's very little carbon build-up and nothing seems excessively worn. And it's now very obvious that the engine has had some top-end maintenance recently. Considering the condition of the rest of the bike, I was expecting all of these parts to look much worse than they do. Inspecting the cylinder shows that at some stage an iron sleeve has been fitted. You can see the change in material here. From the factory, this bike had a chrome plated bore. While this is a hard, durable finish, it cannot be bored oversize. The only options for a worn plated cylinder is to replate or fit an iron sleeve. Here I'm measuring the current bore diameter. The standard bore diameter is 67.00mm with a service limit of 67.070mm. Our measurement is 67.97mm. That's 1mm oversized. So I'd say this sleeve's been in here for a while and has been overbored a couple of times since. And measuring the piston gives us 67.72mm. So, if we work out the difference between the two, we'll have the piston to cylinder clearance, which in this case is 0.25mm. The service limit is supposed to be 0.12mm, so we're over double that figure. Could that be the cause of the piston skirt damage? And maybe that's why the bike didn't run long after the rebuild it looks like it's had. I'm not sure, but for this project it'll need to be rectified. We'll continue the engine strip down and assessment on the next episode of the RM250 project. Thanks for watching, see you next time.